This problem 11 deals with triangles and measures the interior angles of a triangle, and they're talking about the interior angles of any triangle is 180 degrees, and then in particular this triangle ABC. So I'm going to draw a triangle ABC. Now, you just draw a triangle. It doesn't have to be to scale or anything, but I'm going to label it like this: A, B, and C. So this is triangle ABC. Now these angles here, right here, and here, and here, these are the interior angles because they're inside the triangle itself. And if we measure this angle, and measure that angle, and add up those three measures in any triangle at all, that's going to be 180 degrees. That's true for every triangle. Now, in our triangle here, we are told that angles A and B, they have the same measure. And what about angle C? Well, angle C, we're told, is 81 degrees larger than the measures of A and B. So angle C is given in terms of A and B. So if we knew these measures here for A and B, we could get angle C just by adding 81. So since A and B have the same measure, why don't we do this? Why don't we let A be X, and then B will be X also, and then C, well, C is 81 degrees larger than A and B, so this is going to be X plus 81. And now we know that when we add these measures, X to X to X plus 81, when we add those measures, we're going to get 180 degrees. So we'll take X plus X, there's A and B, plus C, X plus 81. That's going to give us 180, and there's our equation. Let's solve it. From here, we'll get 3x plus 81 equals 180. Let's subtract that 81. So we'll get 3x equals, now 180 minus 80 is 100, and one more is 99. Divide by 3, we'll get x equals 33. So now we've got x, right? And what is x? Take it all the way back. X is the measure of A and also the measure of B. But we have one more to get, and that's the x plus 81. So I'll just write that right below it here. X plus 81 is, now I've got x right there, 33 plus 81. So 33 plus 81, 3 and 1 is a 4, and 11. So let's summarize what we have. Here's angle A. Here's angle B. Here's angle C. Angle A has measure, okay, what was A? A was this one, that was X, and we found X to be 33. So this is 33 degrees. B is the same as A, that's 33 degrees. And C, well, C, that was our X plus 81, and that's down here, that's 114 degrees. And we could check by adding those up, and if you do that, you'll see we get 180 degrees. There we go. Problem number 12, we're looking at the numbers on two consecutive gym lockers, and we know that if we add those two numbers, those two locker numbers, we get 143. All right, so we need to introduce a variable. So how about if we did something like this? Let's get an idea of what's happening. Here's one gym locker. Here's another gym locker, and these are right next to each other. So this is locker, say the first locker, this is the second. Now, let's just suppose that we had this. What if this was locker number 10? This would have to be 11, right? Because they're consecutive. That's what it means to be consecutive, one right after the other. Now, if this one here was 25, this one would be 26. If this one was 100, this would be 101. If this one was X, this one would be one more, X plus 1, right? Does that make sense? That every one of these numbers is one more than this number. So whatever number I choose here, if I'll have to add 1 to it to get to the next one. So there's our two locker numbers, X and X plus 1. And I know that if I add those together, if I take X and add the X plus 1, the next one, that I get 143. We can solve this equation now. We'll get 2x plus 1 is 143. Subtract that 1, we'll get 2x equals 142. Divide by 2, we'll get x equals 2 into 14 is 7. 2 into 2 is 1, so we'll get 71. And then that's, what is x? It's a word problem, right? So what is x? X is going to be our first locker number. X plus 1 is the second locker number. So our X plus 1 is, and there's our X, what do we get here? 71 plus 1, we get 72. So what are the locker numbers? They're 71, 72.